All right. Hi, guys. This is video number 7. And it is about domain and range. And you may be a little bit familiar with these terms, but this is kind of an odd concept. And I'm going to do kind of a lot of visuals for you. This might be a long video. I apologize in advance. So just bear with me. But there's a lot of information that you're going to need to recall as your math career goes on. So some of the first things you need are some vocab. And the first thing is a relation. Well, a relation is any set of input and output values. And here's an example. If I have a little table, maybe an X and a Y table, and you're told that Y is equal to 2X. Well, you're going to pick values for your X, let's say -1, 0, and 1. You'd plug them in, and let's see, 2 times -1 is -2, 2 times 0 is 0, and 2 times 1 is 2. These would be your input values. Let me scroll down just a touch. These would be your output values. And the set of input and set of output gives you a relation. So this is also, that should be the word or it is any set of ordered pairs. And remember, an ordered pair when you're graphing is X comma Y enclosed in a set of parentheses. The X is always just real quick, X is always this direction on a graph. The Y, if we make that green, is always this direction. I think Y, yo-yo, they go up and down. So whatever, helps you out. Okay, next, a relation. So your domain is all of your X values in a relation. So they are also your input values. Okay, that's your domain. Your range is all of your Y values in a relation, or your output values. And then a function. A function is a mathematical rule that pairs each element in one set i.e. your input values, each element in one set with exactly one element in another set, i.e. your output. Okay, and kind of a note here. So your X values must be unique or not duplicated for you to have a function. Okay, so let me show you an example. If you see an XY table that looks like this, -2, -1, 0, 1, 2, and the Y values go 3, 2, 1, 2, 3. This statement over here in red says your x values must not be duplicated for this to be a function. As long as every single one of your x values are completely different from each other, then you have a function. So yes, this would be a function. If we had another xy table that looked like this, -2, -1, 0, -1, -2, and this was 5, 4, 3, 4, 5, because this -2 is duplicated, that alone makes it not a function. You also happen to have a -1 duplicated, so this would be not a function because those values are duplicated, okay? You're going to see some questions in varsity that look like this. You're going to be given a set of ordered pairs. And they might look like 2, 3, 4, 5, 6, 7. And then you're going to be asked for the domain. And you'll be asked for the range. And then you're going to be asked if it's a function. Now, this is going to be a yes or no. I think it's a drop-down box, so you get to pick. But here's how you're going to tell. You're going to write down your domain values. Well, the domain values are all of the x's, right? So we have a 2, a 4, and a 6. So that would be your domain. 2, 4, 6, the numbers that are the x values, okay? Your range values are the y's, and those are 3, 5, 7. So as long as these values are not duplicated, then it's a function. Okay. If it is duplicated, let me give you an example. Let's say you're given 1, 2, 1, 3, 2, 4, and I'll go and put 2, 3 in here. Okay, when you write your domain and range, you are not going to duplicate anything. Here's what I mean by that. If you're asked for the domain, remember, x's, input values. 1, here's another 1. I'm just going to ignore that one. 2, here's another 2. I'm going to ignore that one. So my domain is 1 and 2. Now, do I have duplication in my domain? Yes, I do. So this is going to be not a function. Again, because there's 2 1s and 2 2s. So then when I write my range, again, that's y's. My y's are 2, 3, 4. Here's another 3. I already have that. So I'm going to go 2, 3, 4, and that would be my range. Now, your range, it doesn't matter if there's duplication here. There can be. You can have duplication in the range and still be a function. The only thing that matters is your domain. If there is duplication in your domain, then that is not going to work. It doesn't matter also, I just kicked my dog under the table. Sorry, Dixie. It doesn't matter if there's letters in those. The domain can be letters. They can be animals. They can be words. It doesn't matter what those are. So you're going to see some examples in varsity that'll have letters in there instead. I don't feel like I need to give you all of those examples because there's quite a bit of other things to do here. So One more thing I want to point out. Let's say, oh, that's coming up. That was the one I wanted to hit. All right. Let's say if you have this, you are given in varsity, you're going to be given something that'll say y equals 4x, and then you'll have a semicolon, and it's going to say -2 is less than or equal to x, excuse me, is less than or equal to 1. Well, this is telling you your domain values. This says that everything between -2 and 1 is going to be your x's. So there's going to be a table already set up in varsity. And it's going to look like this. It's going to say x and y, and it'll say -2, -1, 0, 1. And then there will be blanks over here. So you'll have to figure these out. Okay, so you're just going to plug the x value up here into the function, right? And then solve, and whatever you get, you get. So if I put a -2 in for x, 4 times -2 is -8. Then I put -1 in, so 4 times -1 is -4. Put 0 in, you always get 0. Put a 1 in, I get a 4. So now my domain is going to be -2, -1, 0, and 1. My range is going to be -8, -4, 0, and 4. Is it a function? Yes, it is, because in these values, there is no duplication. Okay. Another way to represent these ordered pairs is what's called a function map. What it looks like is two little eggs. So you have one here and one here. All of your domain values are always listed on the left, your range on the right, which also you could say these are your input values, these are your output values. And this is the way one of these little function maps would look. Inside, you would have your domain values. On the other side, you're going to have your range values. Let's go 0, -4, +4, -8. And then they just get matched up with a line. So -2 goes to -8. So -2 goes to -8. 1 goes to -4. 0 goes to 0. And 1 goes to 4. And that's what a map would look like, a function map. Okay. Also, one other thing you should know before we go and look at these graphs, which is kind of where the craziness on these comes into play, that function notation, actually, let me just go down here. So function notation looks like, and you may have seen this in a prior class, that's what function notation means. So this is said f of x, which means a function in terms of the variable x. So this whole statement right here, a function in terms of x, is what that looks like mathematically. Okay. And you might see something that looks like this. F of x equals 3x plus 2. Well, there's another thing that you need to know, that f of x means y. So if you see f of x, you could put a y there. So this is really y equals 3x plus 2. And you should know that that's a line in the form of y equals mx plus b, right? So you can always replace an f of x with a y. That is something that I'll talk about as we go back through function notation. And just the actual notation. F of x is f parentheses x. So you can take the word function and just do that in math instead of writing out function notation. All right, so now let's go bring back a few more things. I need to talk about with you how to tell if a graph is a function. And so there is something called a vertical line test, where you would take a picture of a graph that's already there, and you run a bunch of vertical lines through it. Okay, so I'm going to do that. I'll take number 1 here. I'll run a bunch of vertical lines through this thing. Those are vertical, up and down, right? Then here's how this works. If every vertical line you draw touches the graph in only one place, then the graph is a function. Okay, so specifically, if we look at the one that I did here, I'm going to circle in green every place my red vertical line intersects with the graph. That one intersects there, no place else. The second line intersects here, no place else. The third line intersects here, no place else. The fourth line intersects here, no place else. The fifth line intersects here, no place else. So yes, this would be a function. Okay. We're going to use this for something different in a minute, but we need to talk about that vertical line test and what it means. Let me draw a picture on top of number 1. If I draw on there a parabola. Now, a parabola goes, this is not a, I guess, super picture. Let me redo that. Parabolas go up and up and up and out and out and out forever and ever and ever. So that way, that's a better parabola. Okay, so if that was the graph you had and you drew a bunch of vertical lines through that, do the vertical lines hit the parabola in one and only one place? Yes, they do. So yes, that parabola would be a function. Can you think of anything that wouldn't be a function? I know we're not having like a, you're doing this at home, but can you think of something that wouldn't be a function? What if I turn that parabola sideways? Oops, I need a pen. So what if my parabola, instead of the way it was, looks like this? Well, now if I draw a red line through there, I'm good if I go right through the vertex. That hits only at this one place. But as soon as I go somewhere else, this now hits, this one vertical line hits in 2 places. So no, that would not be a function. Okay? Can you think of anything else that might not be a function? What about a shape that wouldn't be a function? So we can actually draw circles, right? When we graph. So if I graphed a circle that looked like that, then if I take and draw a vertical line through that thing, bloop, it's going to intersect my circle in 2 places. So no, a circle would not be a function either. Okay, so that's your vertical line test. You, the person doing the test, runs a bunch of lines through there, and if it doesn't hit the graph, if it hits the graph more than once, it's not a function. I never know if I should word that in the positive or the negative when I do that. So, all right, so let's get rid of this. Now, the reason these graphs are all here are to discuss with you more about domain and range. So we need to, I'm going to erase what I have up at the top. All right, so I got to erase this stuff. And we need to go back to the idea of interval notation that we discussed when we did absolute value in our last chapter. So, interval notation. Recall that you used open parentheses for open dots and brackets for closed dots. And you used parentheses for positive or negative infinity, right? So when you do domain and range of a graph, we have to list every single possible thing on the graph that's being used up. So remember that your domain is your x's. So this is your x values, all of them. Okay, your range is your y values. Oops, hey, that needs to go away. Is your y values. And so I think the easiest way to do these is to label ordered pairs on the graph. Here's what I mean by that. This point right here is an open dot, so it's going to get parentheses. I mean, I know it would anyway because it's an ordered pair, but think outside the box just a little bit. And this ordered pair would be -6 for the x value and 4. -6 and 4. And this dot down here is going to be 4, -5. Okay. Now, when you do your domain and range, we always want to go from least to greatest. I don't have enough room here. Let me erase this stuff. If you don't have it, rewind. Okay. And when you list your domain and range, you always go from least to greatest, smallest to biggest. Okay, so if we take a look, remember an ordered pair is x comma y. So our x values here, I'll do my, let's do our domain in purple. Okay, so my domain values are going to be the x values. And we want to go least to greatest. So this graph goes from -6 to 4 on the x-axis. And that happens to be where your ordered pairs are. And if these are open dots, we're going to have parentheses around them. So always least to greatest with a comma in between. So this means you're going from -6 up to -4, and there's no interruptions in that graph. Okay. Your range is your y values. So that one is 4 and -5. Those are your y values, right? Always the y values in the graph. So we want to go from least to greatest. Well, -5 is much less than 4. So our range is going to go -5 to 4. All right. Here's another visual for you. I'm going to use like a curtain to go across. I'm going to erase what's on the graph. You don't have to. You should leave that on yours probably. You should have drawn that graph, by the way. All right, so I'm going to drag this window here down. And for our domain is x's, which is left and right. So I'm going to move this curtain, and we're going to go from the least value. So when I open this up, notice here I'm at -10 right here, but there is no part of the graph that we're using yet. So we're going to keep going to the left, and oh, there's a dot. Okay, well, that dot appears at -6. So when you list your domain, that should be the first thing that gets listed is -6. If it's an open dot, it gets a paren. If it's a closed dot, it would get a bracket down here. And then we're going to just keep moving. As long as the line is continuous and there's no breaks in this graph, keep going, keep going. We're still using x values. We're still using x values. Keep going, keep going, keep going. Oh, there's a dot. Okay, so we're going to go up until we get to 4. And then we can't go any further because, I mean, if you look over there, there's nothing else on the graph. So we're going from -6 to 4. Okay, you can do the same thing with your y values. Go least to greatest. So I'm going to uncover from the bottom of the graph up. And the first time I get to something in the graph is that point right there, which is -5. So that's going to come first, even though it's on the right side of the picture. It's the lowest point in the graph. So -5, we go up, 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 until we get to, oh, there's our dot. And that dot is at a height of 4. And so that's going to be our value. Okay. So let's list the domain and range for number 2 right here. I like the actual writing of the ordered pairs on the graph. So this ordered pair, bracket, bracket, it is going to be at -1, -5. This ordered pair, also brackets, because it's a solid dot, right? Solid dot gets you brackets. That is at 6, 3. Okay, so we take a look at only our x values. Only our x values. We're at 6 and -1. And so when we write our domain, we're going least to greatest. So -1 to 6, and they're both in brackets. Okay, done. In your range, y values, least to greatest, again, both in brackets. So our range is going to be -5 up to 3. Okay, let's take a look at the next one. Write the ordered pairs down. This first one, open dot. So it's going to get parentheses, and it's going to be at -4, -4. The closed dot is going to get brackets and be at 6, -6. And so now I'm going to look at only my x values. Whoops, did that in the wrong color because I want to be consistent for you guys. -4, 6. And so I'm going to go list from least to greatest. So least, -4 with a parenthesis, up to 6 with a bracket, because this bracket is here. Even though it's facing the wrong direction, the 6 has a bracket. So you need to make it face the right way based on where it's placed in the ordered pair. Okay. Now your range for this guy goes, let's highlight those in green like we did in the last problem, -4, -6, and we're going least to greatest. So the -6 is the smaller value. So we're going -6. That -6 has a bracket around it. And we're going up to -4 with a parenthesis. Okay? Here's what I want you to do. Pause this video for a minute and try numbers 4, 5, and 6. Turn it back on. Maybe do them in pencil or do them on a separate sheet of paper if you're unsure. But you should try those and see if you can label them, and then come on back and see what they are. Okay, so hit pause, give that a try. I'll give you a couple seconds, turn me back on, and then let's fill these in. All right, welcome back. So hopefully you gave these a try, and I'm just going to go through here and identify my ordered pairs really quickly. So this is -4, 4, bracket. This one is 5, 4, bracket. Okay, so my domain goes from -4 to 5, bracket on both. My range is the same exact value. So I'm just going to have a 4 in my range. Okay. If I asked you if this was a function, bump, 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 what would you say? Function, yes. Okay, next one. Ordered pair. -7, 0, and 3, 6. So domain, -7 to 3, bracket on the left, paren on the right. The range would be 0 to 6. bracket on the left, parenthesis on the right. Okay. 6 is kind of tricky. It's a little bit like 4. Our ordered pairs, they're both going to be brackets. This is going to be 7, 2, and 7, negative 7. Okay, so our domain only has one value, and that's a 7 with brackets. But our range goes from negative 7 to negative 2. Okay, always, oh, sorry, positive 2. Always least to greatest. Make sure, always, always, always least to greatest. Okay? Hopefully that went okay for you. Here's a couple more you can try. All right, if you'd like, you can try 13, 14, and 15 up here. Okay, pause, come on back, and put some information in, and then we'll talk about 16 in a minute. Okay, so these guys, if you labeled these, this one is 0, 4. If you have trouble labeling ordered pairs, this is really difficult for you. And this is going to be 5, negative 7. And so our domain here is going to be 0 to 5, 0 to 5, bracket paren. And our range is going to be negative 7 to 4, paren, bracket. All right, this guy, just in case you actually did these, are going to be, this point is negative 5, negative 5, parens. This is 5, 0 with brackets. So our domain is negative 5 to 5, paren, bracket. And our range is negative 5 to 0, paren, bracket. Like this guy over here, this is 1, negative 6 with brackets. This guy is 8, 2 with brackets. And so our domain X values go from 1 to 8, brackets on both. Our range goes from negative 6 to 2, brackets on both. Okay, let's throw a curveball in. Anytime your graph changes direction, I want you to plot a point at the change of direction. So we're going to plot a point right here on this graph, and then we are going to identify all of these. So this point here is at negative 9, negative 8. This middle point that we just plotted is at 2, 3. Oh, brackets. I should have put brackets on this one too. Sorry about that. Don't want to confuse anybody. And then this guy is also going to get brackets at 5, negative 4. Okay, so we're going to do the same thing we did before, but now you only need to include 2 of these points. So we're going to ignore one of them. So our X values are oh, I did it again. I want yellow. Okay, our X values are negative 9, 2, and 5. So we're going to go from least to greatest. So negative 9 is our smallest one. So that's going to be our first one in a bracket. 5 is our biggest one. And so we're going to ignore the 2 because it gets encompassed in the graph. It goes straight across all the way through. So 9 to 5, negative 9 to 5. All right, so you're going to literally do only your least, only your greatest, ignore the middle one. So here's my highlighter, green, my Y values, negative 8, negative 4, and 3. Well, negative 8's the littlest one, 3's the biggest one, so we're going to ignore the negative 4, and we're going to go negative 8 to 3. Okay? On this next one, we would have an open dot here. So this is negative 9, 7. We're going to add a dot where it changes direction. So that's negative 4, negative 7. We're going to add another dot where it changes direction. And that's going to be 3, 2. And then this last dot is going to be 5, negative 5. Okay, so similar to what we did just a moment ago, highlight all of your x's, -4, -9, 3, and 5. We're going to start with our lowest one, which is -9, and the biggest one is 5, so we're going to ignore the -4, ignore the 3, and this is going to go from -9 with a parenthesis to 5 with a bracket. Okay, and then the y values, we're going to go -7, +7, 2, -5. -7 is the lowest. +7 is the highest. So we're going to ignore, and use the two values you're given. -7 is the smallest with a bracket. +7 is the largest with a parenthesis. All right. If you want to give this next one a try, you can pause and do that. And I'm going to just list it without actually putting anything on here. So pause, you list it, write it down, come back and check. So your domain here goes from -5 to 5, and those are going to be brackets. And the range goes from 0 to 7, also with brackets. How'd you do? All right, now let's talk about the last couple things here. If we have, I told you this will be a long one. I'm sorry, but it's necessary that you understand how these are working. All right, so when you have an arrow on the end of one of these, I want you to write it as an ordered pair with infinity. And here's what I mean. This graph is going this way forever and ever and ever. So your x value is going to be a positive infinity. And it's also going up forever and ever and ever. So your y value is also going to be a positive infinity. And these would get brackets, or I'm sorry, parentheses around them. Okay, so this is like a combination of a positive x, positive y. If you know anything about vectors, this is kind of the same idea. So I want to do that with a couple of these before we actually identify your domain and range. This guy right here. Okay, which way is he going? Well, that's a combination of this way and this way. So your x value, this guy is going towards negative infinity in the x direction because it's going left, and it's going up, which is positive infinity on the y. Okay. Let's take a look at this arrow right here in problem 22. That is a combination it is going to the left and it's going down, which means it is left means negative infinity on the x, y means negative infinity on the y. Okay, or down, I'm sorry. And then this guy, that's a combination of right, which on the x-axis is infinity, and down, which on the y-axis is negative infinity. And so that's going to be the ordered pair for that arrow. Okay. Likewise, this arrow, very much like the one we just did up here in problem 21. 23, this is a combination of left and up. So that would be negative infinity on the x, positive infinity on the y. This arrow is a combination of right and down, which would be infinity for x going to the right, negative infinity for the y. Okay. So now let's take a look at actually doing some of the domain and range. Let's go back to problem 20. This guy up here, we did not identify this point, but that point is with a bracket, -7, 2. Okay. And your x values go from -7. You know what happened. -7 and infinity. Well, which one's lower? That happens to be the negative infinity in this one. So we're going to go, I'm sorry, -7. -7 is our lowest one with a bracket, to infinity with a parenthesis. Similar with your y values, green. So they go from 2 to infinity. 2 is clearly lower. So 2 with a bracket to infinity with a parenthesis. Okay. Let's do number 21. This one in the upper right-hand corner. This point right here is the origin, 0, 0. It's an open dot, so it gets parentheses. If we look at our x values, we have a 0 and a negative infinity. Well, which one's smaller? Negative infinity is smaller. So we're going to go negative infinity to 0. And then when we do our y's, we have a 0. I'll do this one in red. 0 and infinity. And so we're going to go 0 is smaller to infinity. Right? I guess maybe if you're having trouble with these infinity things, look at number 19, and I'm just going to write on the graph a little bit. Okay? As y goes up, this goes towards infinity on the y. As y goes down, it goes towards negative infinity. Right? As x goes left, it goes towards positive infinity. As x goes, did I say x goes left up here? This is right. You all know that, right? Maybe I don't. And then this side, if x is going left, that is going down to negative infinity. Right? So that's how I'm labeling these, if you were a little confused about that. These, again, take some practice. So I already labeled the points for 22 and 23. If you look at your x values for your domain, negative infinity, positive infinity. Well, negative infinity is always less than positive infinity, and infinities are always in parentheses. Your range, negative infinity to negative infinity. How high does it go, though? We didn't do this changing point up here. Remember, it changes directions right here. It's going this way, then it changes, goes this way. So this point is 0, 6. And so we have negative infinity down here, negative infinity over here, a 6 up here. We're going to ignore one of these. And this thing is going to go from negative infinity all the way up to 6. Bracket, paren. All right. Let's do number 23. We did this arrow, which was negative infinity, positive infinity. We did this arrow, which was infinity, negative infinity, and there's no changes of direction in this graph. So our x values are going to go from negative infinity to infinity, parentheses, and our y values are going to go from negative infinity, remember the lowest one, to infinity. Okay, lowest to highest, all the time. And then for 24, why don't you pause, see if you can write the ordered pairs. All right, so if you paused, this arrow over here on the left is a combination of left and up, which would be negative infinity, infinity. This arrow over on the right is a combination of right and up, which is infinity, infinity. And we have to do this change of direction point, which is -3, -5. Okay, so now if we take a look at our ordered pairs here, we have negative infinity. Let me change to yellow again. Keep doing that. Negative infinity, positive infinity, and -3. So the -3 doesn't really matter here because it's contained between our two infinities. So this is going to be negative infinity to positive infinity for our domain. However, for our y value, we do have, that does come into play a little bit. So we have -5, positive infinity, positive infinity. So we're going to ignore one of those positive infinities. And we're going to go -5 with a bracket to infinity with a parenthesis. Okay? All right, I have one more thing down here. I know this has been long, but it's important. If you only have a list of ordered pairs or list of dots, I'm sorry, make a bunch of points on here like we have been. So this is 5, 0. This is 1, 5. This is 0, 3. This is 1, negative 2. This is negative 2, negative 5. This guy's negative 6, 1. And then when you list your domain, you're just going to list all the individual values. So your domain values, let's see if I can do this the right way. All right, yellow. All right, so negative 6, negative 2, 0. 1 is here, but it's also down here, so you don't need that second one. And there's a 5. All right, so we're going to go ahead and list all of these guys, least to greatest. So negative 6, negative 2, 0, 1, 5. Typically, if you have individual values like that, you enclose these in those little French braces. Okay, and let's do the range. So now that you know what we're doing, I'm not going to use a highlighter. I'm just going to circle them. I've got 1, negative 5, negative 2, 0, 5, and 3. We're going to go least to greatest. So negative 5, negative 2, 0, 1, 3, and 5. Oops, French brace. All right. Is this a function up here? Well, if you draw a vertical line through each of these, there's 1, there's 1, there's 1. That one would hit both of those. So that makes it no, not a function. Okay? Oh my goodness. All right, that was a lot of notes. I am sorry. I will try to keep these shorter in the future, but that was a lot of data. So, toodaloo. Go do your varsity and everything else. I can't find how to turn it off.